Hello everyone, welcome to today's session. I hope you all are doing well. So, before moving ahead, please subscribe our channel for more updates. Now, let's move forward, and today's topic is random forest. Well, we'll try to find out the answer to this particular question as to why we need random forest. So, human beings learn from the past experience, and unlike human being, a computer does not have experience. Then how does machine take decisions, and where does it learn from? Well, a computer system actually learns from the data which represents some past experience of an application domain. So now let's see how random forest it's in building up a learning model with a very simple use case of credit risk detection. Now, needless to say that credit card companies have a very nested interest in identifying financial transactions that are illegitimate and criminal in nature. And also, I would like to mention this point that according to Federal Reserve payment study, Americans used credit card to pay for 26.2 billion purchases in 2012, and the estimated loss due to unauthorized transaction here was US 6.1 billion dollars. Now in banking industry, measuring risk is very critical because the stakes are too high. So the overall goal is actually to figure out who can be fraudulent before too much financial damage has been done. So for this, a credit card companies receives thousands of applications for new card, and each application contain information about an applicant. So here, as you can see, from all those applications, what we can actually figure out is that predictor variable like what is the marital status of the person, what is the gender of the person, what is the age of the person, and the status, which is actually whether it is default payment or non-default payment. So default payment are basically when payments are non made in time and according to agreement signed by the cardholder. So now that account is actually said to be in the default. So you can easily figure out the history of a particular cardholder from this. Then we can also look at the time of payment, whether he has been done a regular or non-regular one, what is the source of income of that particular person, and so on and so forth. So to minimize loss, the bank actually needs certain decision rules to predict whether to approve particular loan of that particular person or not. Now here is where the random forest actually comes into the picture. Now let's see how random forest can actually help us in the particular scenario. Now we have randomly taken two parameters out of all the predictive variables that we saw previously. Now we have taken two predictor variables here. The first one is the income and the second one is the age, and similarly, parallelly two decision trees have been implemented upon those predicted variables. Let's first assume the case of the income variable. So here we have divided our income into three categories. The first one being the person earning over $40,000, second from $15,000 to $40,000, the third one earning in the range of $0 to $15,000. Now, if a person is earning over $40,000, which is pretty good income, pretty decent. So now we'll check out for the credit history. And here the probability is that if a person is earning a good amount, then there's a very low risk that he won't be able to pay back. He's already earning good. So the probability is that his application for a loan will get approved. So this actually low risk or moderate risk, but there's no real issue of higher risk as much. We can approve the applicant's request here. Now let's move on and watch out for the second category where the person is actually earning from $15,000 to $40,000. Now here the person may or may not pay back. So in such scenarios, we'll look for the credit history as to what has been his previous history. Now if his previous history has been bad, like he has been a defaulter in the previous transaction will definitely not consider approving his request, and he will be at high risk, which is not good for the bank. If the previous history of that particular applicant is really good, then he will just clarify a doubt and consider another parameter as well that will be in depth. I have him already in a really high dip, then in the risk again increase, and there are chances that he might not repay in the future. So here will not accept the request of the person having high debt. If the person is in the low debt and he has been a good payer in his past history, then there is a chance that he might be back, and we can consider approving the request of this particular applicant. Now let's look at the third category, which is a person earning from 0 to $15,000. Now this is something which actually raises me, and this person will actually lie in the category of high risk. So the probability is that his application for a loan would probably get rejected. Now we'll get one final outcome from this income parameter. Now let us look at our second variable, that is age, which will lead into the second decision tree. Now let us see if a person is young. So now we will look forward to if it is a student. Now if it is a student, then the chances are high that he won't be able to repay back because he has no earning source. So here the risks are too high, and probability is that his application of loan will get rejected. Now if the person is young and he's not the student, then we'll probably go on and look for another variable, that is his bank balance. Now let's look if the bank balance is less than 5 lakhs. So again, the risk arises and the probabilities that his application of loan will get rejected. Now if the person is young, is not a student, and his bank balance is greater than 5 lakhs, is a pretty good and stable bank balance, then the probability is that his loan of application will get approved. Now let us take another scenario if he is a senior. So if he is a senior, will probably go and check out for his credit history. How well has he been in his previous transaction? What kind of person he is, like whether he is a defaulter or he is a non-defaulter. Now if he is a very fair kind of person in his previous transaction, then again the risk arises and the probability of his application getting rejected actually increases. Now if he has an excellent person as per his transaction in the previous history, so now again here there are least risk and the probabilities that his application for a loan will get approved. So now these two variables, income and age, have led to two different decision trees. And these two different decision trees actually led to two different results. Now what random forest does is it will actually compile these two different results from these two different decision trees, and then finally it will lead to a final outcome. That is how random forest actually works. So that is actually the motive of the random forest. Now let us move forward and see what random forest is. You can get an idea of the mechanism from the name itself, random forest. So a collection of tree is a forest. That's why I called a forest probably. And here also the trees are actually because of being trained on subsets which are being selected at random, and therefore they are called random forest. So random forest is a collection or an ensemble of decision trees. Here decision trees actually built using the whole data set considering all features, but actually in random forest only a fraction of the number of rows is selected, and that too at random, and a particular number of features which are actually selected at random are trained upon, and that is how the decision trees are built upon. So similarly, a number of decision trees will be grown, and each decision tree will result in a certain final outcome. And random forest will do nothing but actually just compile the result of all those decision trees to bring up the final result. As you can see in this particular figure, that a particular instances actually has resulted into three different decision trees. So now tree 1 result into a final outcome called class A, and tree 2 result into class B. Similarly, tree 3 result into class C. So random forest will compile the result of all these decision trees, and it will go by the call of the majority voting. Now since here two decision trees have actually voted into favor of the class B, that is decision 2 and 3. Therefore, a final outcome will be in the favor of class B, and that is how random forest actually works. Now, one really beautiful thing about this particular algorithm is that is one of the versatile algorithms which is capable of performing both regression as well as classification. Now, let's try to understand random forest further with a beautiful example, or this is my favorite one. So, let's say you want to decide if you want to watch Edge of Tomorrow or not. So in the particular scenario, you will have two different action to work on. Either you can just straight away go to your best friend, ask him about whether I should go for Edge of Tomorrow or not. Will I like this movie? Or you can ask bunch of friends and take their opinion, consideration, and then based on the final result, who can go out and watch Edge of Tomorrow. So now let's just take the first scenario. So when you go to your best friend, ask about whether you should watch The Edge of Tomorrow or not. So your friend will probably ask you a certain question, like the first one being general. So let's say your friend asks if you really like the adventurous kind of movies or not. So if you say yes, definitely I would like to watch the adventure kind of movies. So the probability that you will like The Edge of Tomorrow as well. Since Edge of Tomorrow is also a movie of adventure and sci-fi kind of genre. So let's say you do not like the adventure genre movie, then again the probability reduces that you might really don't like Edge of Tomorrow. So from here you can come to a certain conclusion. Let's say your best friend puts you into another situation where he'll ask you, or do you like Emily Blunt? Or you see, definitely I like Emily Blunt. And then he puts another question to you, do you like Emily Blunt to be in main lead? And you say yes. Then again the probability arises that you will definitely like Edge of Tomorrow as well, because Edge of Tomorrow has Emily Blunt in the main lead cast. So if you say I do not like Emily Blunt, then again the probability reduces that you would like Edge of Tomorrow too. So this is one way where you have one decision tree and your final outcome. Your final decision will be based on your one decision tree, or you can see your final outcome will be based on just one friend. Now definitely they are not really convinced. You want to consider the opinion of your other friends also, so that you can make very precise and crisp decisions. You go out and you approach some other bunch of friends. Now let's say you go to three of your friends and you ask them the same question, whether I would like to watch Edge of Tomorrow or not. So you go out and approach three of your friends, friend 1, friend 2, and friend 3. Now you will consider each of their votes, and then your decision now will be depend on the compiled result of all of your three friends. Now here, let's say you go to your first friend and you ask him whether you watch Edge of Tomorrow or not, and your first friend asks you one question: did you like Top Gun? And you say yes, definitely I did like the movie Top Gun. Then the probability that you would like Edge of Tomorrow as well, because Top Gun is actually a military action drama, which is also Tom Cruise. So now again, the probability rises that yes, you will like Edge of Tomorrow as well. And then if you say no, I didn't like Top Gun, then again the chances are that you wouldn't like Edge of Tomorrow. And then another question that he puts you across is that do you really like to watch action movies? And you say yes, I would love to watch them again. The chances that you would like to watch Edge of Tomorrow. So from your friend, you can come to one conclusion. Now, since the ratio of liking the movie to don't liking is actually 2:1, so the final result is actually you would like Edge of Tomorrow. Now, you go to your second friend and you ask the same question. So now your second friend asks you, did you like Far and Away when he went out and did the last time when we watched it? And you say no, I really didn't like Far and Away. Then you would say, then you are definitely going to like Edge of Tomorrow. Why is it so? Far and Away is actually, since most of whom might not be knowing, is so Far and Away genre of romance, and it revolves around a girl and a guy by falling in love with each other and so on. So the probability is that you wouldn't like the Edge of Tomorrow. So he asks you another question: did you like Oblivion? And you say yes. The probability is that you would like to watch Edge of Tomorrow. Why? Because Oblivion again is a science fiction casting, Tom Cruise full of strange experience, and when Tom Cruise is a savior of mankind, well, that is the same kind of plot in Age of Tomorrow as well. So here is pure yes that you would like to watch The Edge of Tomorrow. So you get another second decision from your second friend. Now you go to your third friend and ask him, so probably our third friend is not really interesting in having any sort of conversation with you. Say it just simply asks you, did you like Godzilla? And you said no, I didn't like Godzilla. We said definitely you wouldn't like it. So for tomorrow, why so? Because Godzilla is also actually science fiction movie from the adventure zone. So now you have gone three results from three different decision trees from three different friends. Now you compile the result of all those friends and then you make a final call that yes, would you like to watch Edge of Tomorrow or not? So this is some very real time and very interesting examples where you can actually implement random forest into ground reality. Now we can move forward. Now let us look at various domains where random forest is actually used. So because of its diversity, random forest is actually used in various diverse means. So beat banking beat, medicine beat, land use beat, marketing name it, and random forest is there. So in banking, particularly, random forest is being actually used to make it out whether the applicant will be default, a pair, or it will be non-default or one. So that is can accordingly approve or reject the applications of loan. So that is how random forest is being used in banking. Talking about medicine, random forest is widely used in the medicine field to predict beforehand what is the probability if a person will actually have a particular disease or not. So it's actually used to look at the various disease trends. Let's say you want to figure out that is a probability that a person will have diabetes or not. And so what would you do? It the probability look at the medical history of that patient and then you will see this has been the glucose concentration. What was the BMI? What were the insulin level in the patient in the past 3 months? What is the age of this particular person? And will make a different decision tree based on each of these predictor variables and then you'll finally compile the result of all those variables, and then you will make a final decision as to whether the person will have diabetes in the near future or not. That is how random forest will be used in the medicine sector. Random forest is actually used to find out the land use. For example, I want to set up a particular industry in a certain area. So, what would I probably look for? I look for the vegetation over here, what is the urban population over there, and how much is the distance from the nearest modes of transport, like from the bus station or the railway station. And accordingly I will split my parameter, and I will make a decision on each of these parameter, and finally I'll compile my decision of all these parameters, and that will be my final outcome. So that is how I'm finally going to predict whether I should put my industry at this particular location or not. So these three examples have actually been majorly around classification problem, because we're trying to classify whether or not. We're actually trying to answer this question whether or not. Now let's move forward and look at how marketing is revolving around random forest. So particularly in marketing, we try to identify the customer churn. So this is particularly the regression kind of problem. Now, how we'll see, customer churn is nothing but actually a number of people which are actually a number of customer who are losing out. So we are going out your market. Now you want to identify what will be your customer churn in the next future. So most of e-commerce industries are actually using like Amazon, Flipkart, etc. So they particularly look at each behavior as to what has been your past history, what has been your purchasing history, what do you like based on your activity around, certain things around, certain ads around, certain discount, or certain kinds of materials. If you like a particular top, your activity will be more around the particular top. So that is how they track each and every particular move of yours, and then they try to predict whether you will be moving out or not. So that is how they identify the customer's churn. So these all are the various domains where random forest is used, and this is not the only list. So there are numerous other example which actually are using random forest, that makes it so special actually. Now let's move forward and see how random forest actually works. So let us start with the random forest algorithm first. Let's just see it step by step as to how the random forest algorithm works. So the first step is to actually select certain m features from T, where m is less than T. So here T is the total number of the predicted variables that you have in your dataset, and out of those total predictor variable, you will select some features out of those. Now, why we are actually selecting a few features only? The reason is that if you select all the predictive variables or the total predictor variable, then each of your decision tree will be the same. So the model is not actually learning something new. It is learning the same previous thing because all those decision trees will be similar. If you actually split your predicted variable and you select randomly a few predicted variables only, let's say there are 14 total number of variables, and out of those you randomly pick just 3. So every time you will get a new decision tree, there will be a variety. So the classification model will be actually much more intelligent than the previous one. Now it has become a barrier to experiences. So definitely it will make different decision each time, and then when you compile all those different decisions, it will be the more accurate and efficient result. So the first important step is to select a certain number of features out of all the features. Now let's move on to the second step. Let's say for any node D. Now the first step is to calculate the best split at that point. So you know that decision tree are actually implemented. So you pick up the most significant variable and then you will split that particular node into for the child nodes. That is how the split take places. So you will do it for m number of variables that you have selected. Let's say you have selected 3. So you will implement the split at all those 3 nodes in one particular decision tree. The third step is split up the node into 2 daughter nodes. So now you can split your root node into as many nodes as you want to put here. We'll split our node into 2.2 nodes as to this or that. So it will be an answer in terms of this or that. Our fourth step will be repeat all these 3 steps that we have done previously, and we will repeat all this splitting until we have reached all the n number of nodes. So we need to repeat until we have reached the leaf node of a decision tree. That is how we will do it. Now after these 4 steps, we will have one decision tree. But random forest is actually about multiple decision trees. So here our fifth step will come into the picture, which will actually repeat all these previous steps for d number of times. Now hit this the d number of decision trees. Let's say I want to implement 5 decision trees. So my fifth step will be to implement all the previous steps 5 times. So here the iteration is for 5, the number of times. Now once I have created these 5 decision trees, my task is not complete yet. My final task will be to complete the result of all these 5 different decision trees, and I will make a call in the majority weight voting. Here, as you can see in this picture, I had n different instances. Then I created n different decision trees, and finally I will compile the result of all these n different decision trees, and I will take my call on the majority voting. So whatever my majority vote, say that will be my final result. So this is basically an overview of the random forest algorithm and how it actually works. Let's just have a look at this example to get a much better understanding of what we have learned. So let's say I have this data set which consists of 4 different instances. So basically it consists of the weather information of the previous 14 days from D1 to D14. And this basically outlook humidity and wind, and this basically gives me the weather condition of those 14 days. And finally I have played, which is my target variable, whether match did take place or that particular day or not. Now my main goal is to find out whether the match will actually take place if I have followed this weather condition with me on that particular day. Let's say the outlook is rainy that day and humidity is high and the wind is very weak. So now I need to predict whether I will be able to play in the match that day or not. So this is problem statement. Now let's see how random forest is used in this to sort it out. Now here the first step is to actually split my entire data set into subsets. Here I have split my entire 14 variables into further smaller subsets. Now these subsets may or may not overlap, like there is certain overlapping between D1 to D3 and D3 to D6. There is an overlapping of D3. So it might happen that there might be overlapping. So you need not really worry about the overlapping, but you have to make sure that all those subsets are actually different. So here I have taken 3 different subsets. My first subset consists of D1 to D3, my second subset consists of D3 to D6, and my third subset consists of D7 to D9. Now I will first be focusing on my first subset. Now here, let's say that particular day the outlook was overcast. If yes, it was overcast, then the probabilities that the match will take place. So overcast is basically when your weather is too cloudy, and if that is condition, then definitely the match will take place. And let's say it wasn't overcast, then you will consider the second most probable option, that will be the wind, and you will make a decision based on this. Now whether wind was weak or strong. If wind was weak, then you will definitely go out and play the match, else you would not. So now the final outcome out of this decision tree will be play, because here the ratio between the play and no play is 2:1. So we get a certain decision from a first decision tree. Now let us look at the second subset. Now since the second subset has a different number of variables, so that is why the decision tree is absolutely different from what we saw in our first subset. So let's say if it was overcast, then you will play the match. If it isn't the overcast, you would go and look out for humidity. Now further, it will get split into two, whether it was high or normal. Now we'll take the first case. If the humidity was high and when it was weak, then you will play the match. Else, if humidity was high but wind was too strong, then you would not go out and play the match. Now let us look at the second daughter node of humidity. If the humidity was normal and the wind was weak, then you will definitely go out and play the match, as you want to go out and play the match. So here, if you look at the final result, then the ratio of play of match is 3:2. Then again the final outcome is actually play. So from the second subset, we get the final decision of play. Now let us look at our third subset, which consists of D7 to D9. Here, if again the overcast is yes, then you will play the match. Else, you will go and check out for humidity. And if the humidity is really high, then you won't play the match. Else, you will play the match. Again, the probability of playing the match is yes, because the ratio of no play is 2. So they are different subsets, different decision trees, and three different outcomes. And final outcome, after compiling all the result from these three decision trees. So I hope this gives a better perspective and better understanding of random forest, like how it really works. So now let's just have a look at various features of random forest. So the first and foremost feature is that it is one of the most accurate learning algorithm. So why it is so? Because single decision trees are actually prone to having high variance or high bias, and on the contrary, actually random forest averages the entire variance across the decision trees. So let's see, if the variance say X for decision tree, but for random forest, let's say we have implemented n number of decision tree parallelly. So my entire variance gets average to upon, and my final variance actually becomes X upon n. So that is how the entire variance actually goes down as compared to other algorithms. Now the second most important feature is that it worked well for both classification and regression problem. And by far, I have come across this one and the only algorithm which worked equally well for both of them. These classification kind of problem or regression kind of problem, then it really run efficiently on large database. So basically it's really scalable. Even if you work for the lesser amount of database, or if you work for a really huge volume of data, so that's a very good part about it. Then the fourth most important point is that it requires almost no input preparation. Now why am I saying this? Is because it has got certain implicit method which actually take care and remove all the outliers and all the missing data and you really don't have to take care about all the things. While you are in stages of input preparation, so random forest is all here to take care of everything else. And next, it performs implicit feature selection. So while we are implementing multiple decision tree, it has an implicit method which will automatically pick some random features out of all your parameters, and then it will go on and implement different decision trees. So for example, if you just give one simple command that all I want to implement 500 decision trees no matter how. So random forest will automatically take care and it will implement all those 500 decision tree, and those all 500 decision tree will be different from each other, and this is because it has got implicit method which will automatically collect different parameter itself out of all the variables that you have. Then it can be easily grown in parallel. Why it is so? Because we are actually implementing multiple decision trees, and all those decision trees are running, or all those decision trees are actually getting implemented parallelly. So if you say I want 1,000 trees to be implemented, so all those 1,000 trees are getting implemented parallelly. So that is how the computation time reduces down. And the last point is that it has got method for balancing error in unbalanced dataset. Now what exactly unbalanced dataset are? Let me just give you an example of that. So let's say you're working on a dataset and you create a random forest model and get 90% accurate immediately. Fantastic, you think? So now you start diving deep, you go a little deeper, and you discover that 90% of that data actually belong to just one class. Your entire dataset, your entire decision is actually biased to just one particular class. So random forest actually take care of this thing, and it is really not biased toward any particular decision tree or any particular variable or any class. So it has got method which look after it, and they do all the balance of error in your dataset. So that's pretty much about the feature of random forest. This is all about the random forest. If you have any doubt or any query, you can drop in the comment section. In the next session, we will work on the KNN algorithm. So thank you so much guys for watching the video.